Hello everyone. In this video I'm going to be talking about how to convert between different units of measurement. Now this is something particularly that A-level students sometimes struggle with when looking at sort of the ultrastructure of cells, for example, through the microscope and trying to convert between different units. So I'm talking about converting from meters to millimeters, or even looking at things like micrometers, nanometers, and even smaller than that. So what we're going to do is look at the units that typically we deal with, a few tips on how to switch between the two, and then I'll talk about a sort of a real life example and show how it adapts. So let's think about the units that we have in biology particularly. I mean, this applies for all sciences, but I'm just doing it based on my experience of microscopy at A-level. So let's think about meters. So the unit M there. So we know meters are very, very large, but realistically, when we're looking at, again, I'll use the example, a sort of microscope specimen, we're not going to record things in meters. Instead, we might look at using millimeters as a measurement. Millimeters is written as you know, 2 m's. And if we go even smaller than millimeters, we get into something called micrometers. And even smaller than that would be nanometers. So let's put in the units, the symbol for micro there, micrometers, and nm for nanometers. And often in calculations we tend to go back and forth between these units, so it's possible to convert between them all. Okay, so we have our different types of units in place. Now, this is the easiest way I find to remember them. If you're trying to convert in this direction, so going from meters to millimeters, or to micro or to nano, at every step you times by 1,000, and if you're going this way, you divide by 1,000, and that's at every point. So let's just take meters and millimeters for example. If I wanted to convert a value of meters to millimeters, I would times my value by 1,000. And if I want to do the same, go from millimeters to micro, I would then take that number and then times that by 1,000, and likewise times it by 1,000 again to get it into nanometers. And those times by thousands would be divided by, if I was going the other way, because meters, millimeters, micrometers, nanometers, they're all different by a factor of 1,000. Now I know that you can measure in centimeters, but we don't often, when looking at like biological specimens for example, we tend to do it in factors of 1,000. I like to think of it a bit like this. It's a bit of an unusual way to think of it, but this is how I present it almost to my students. I imagine you've got two pillars here, pillar 1 and pillar 2, and I'm trying to fit as many units as I can in this particular space. And again, odd way to look at it, but I think, how much unit can I get in there for my money? I want as much unit as I possibly can. Now, I could get in a certain number of meters in that space between 1 and 2. But I could probably fit in a lot more millimeters. So let's just, this is just very rough, not at all to scale, but Let's say I have a certain number of millimetres in that space there, between 1 and 2. If I'm converting from millimetres to micrometres, the easiest way to think of it is, am I getting more units in my space? And I am, because micrometres are smaller than millimetres. I can fit more micrometres in that given space than I can millimetres. And I always say to my students, if you can fit more in, you times it up. So that's why it's times by 1,000. If you fit less in, divide by 1,000. Now it's a bit of an odd way to look at it, and then it may make sense to some people, may not to others. But let's just think of an actual example using these units, just to put this into a context. So what I'm going to draw here is a red blood cell. Not to scale, or perhaps drawn well, but so draw a red blood cell here. In fact, I'm going to have a sort of darker region in the middle here to represent the fact that it is a biconcave disc, so it has a sort of indentation in. Now, size-wise, we're going to pretend that the diameter of that red blood cell here in this picture is, and we'll say that's about, I don't know, 40 millimetres. We'll say that's about 40 millimetres in diameter. Now clearly it's not drawn to scale. And there is a formula that you can use to work out sort of magnification, actual image size of object, that you can do that to work out the real size. But we're just going to take it as a picture as I've drawn it. We're going to say that's 40 millimetres across. Now, if you were told to express that in micrometres, for example, I'd take my 40 millimetres. I'm going from millimetres to micro, so I'm getting more units in that space, if you like, in that distance, almost between here and here. I can get more micrometres for my money in there. And if I follow my rule of times by 1,000 if I'm going left, divide by 1,000 if I'm going right, I'm going to times this by 1,000. So to go from millimetres to micro, I times by, so I'm looking here at the moment, I times by 1,000. So 40 millimetres in micrometres becomes 40,000, and then you just need to put the units, micrometres. And the number looks massive, it does, and you may be thinking that's clearly wrong because 40,000 is huge, but it's 40,000 micrometres, which is very, very small. So that's right. So 40 millimetres is the same as saying 40,000 micrometres. If we even wanted that in nanometres, we times it by another 1,000. So that would be 40 million nanometres. So that's how you convert between the different units seen here, between metres, millimetres, micro and nanometres. Every time you jump from one to another, depending on which direction you go, you either times it by 1,000 per step or divide by 1,000 for each step. So I tell my students it's quite useful to note this down in their books as a simple way to remember which way to make the number. Okay, I hope that helps.